Hey guys, how would you like to learn to build a custom Alexa skill that will work with any Amazon Echo device to control any TV in your house using your voice and a Raspberry Pi, even if the TV is 10 or 15 years old? Check this out. Alexa, tell my TV to turn on.
Turning your TV on.
Alexa, tell my TV to increase the volume. Alexa, tell my TV to decrease the volume.
Decreasing volume.
Alexa, tell my TV to mute the volume.
Mute volume.
Alexa, tell my TV to unmute the volume.
Unmute volume.
Alexa, tell my TV to channel surf down.
Channel down.
Down.
Channel down.
Down.
Channel down.
Down.
Channel down.
Up.
Channel up.
Alexa, tell my TV to go to channel 55.
Channel change to 55.
Alexa, tell my TV to power off.
Turning your TV off.
Hi, I'm Leah Sam. I'm an inventor, US patent holder, electrical engineer, and university instructor, and I like coming up with cool projects. Check out this tutorial on how to build a custom Alexa skill for Raspberry Pi using Python to control any TV with your voice. Before we get started with our project, it helps to take a look at the entire project overview. There are a lot of moving parts, and it helps to understand how the various pieces fit together. So initially, a user is going to say in our project, Alexa, tell my TV to turn on, or give the TV a specific instruction. That goes to your Amazon Echo device, and a request is sent up to the Amazon cloud to the Alexa voice service. In the Alexa voice service itself, there's some natural language processing that happens and speech-to-text conversion, and what happens is, based on some configuration we would have done for our skill, the request is matched to a specific intent, and you can think of an intent as an action that we want our skill to perform. Various slots or variables are populated for those intents, and then the Alexa voice service calls a skill handler which actually will be running on our Raspberry Pi. So the instructions around how our skill should be processed will be running on a Python program that we will install on our Raspberry Pi. In the case of telling the TV to turn on, the Raspberry Pi will then send infrared instructions to an IR LED in our circuit. That IR LED will send signals to our TV to tell our TV to power on. Once those signals are sent, our skill handler on our Python program will then send a response back to the Alexa voice service. This is sort of a confirmation of the command that was just executed. The Alexa voice service will perform text-to-speech and then send that back to the Echo device, which would relay the response to the user. So as you can see, there's a lot of moving parts here, but really cool, really exciting project. And now that we have an overview of everything that's happening in our project and what's going on in the overall system, let's get a little more hands-on and dive in deeper. Okay, let's talk about the parts that we're going to need for our project. First off, Raspberry Pi 3, and I'm using a Raspberry Pi 3B+, which is the latest model at this time. I'd recommend a Raspberry Pi 3. For your Raspberry Pi, a mouse and a keyboard, which can be a USB mouse and a keyboard. I'm using a wireless USB mouse and keyboard, so I inserted the USB fob into a USB slot. of course, a power adapter for your Raspberry Pi, and optionally an HDMI cable and monitor. Also, you definitely need your micro SD card, and this is what we'll be flashing our operating system on. Next up, for our IR circuit components, you'll need some connecting wires, and here some male to female connecting wires are handy. We also need a couple of resistors. Here is a 330 ohm resistor, and I also have a 100 ohm resistor. Next, we also need an IR LED, and this is the infrared LED that we'll be sending signals to our TV with. And also, we'll need an IR receiver, and this is what we'll use to record signals from our remote. Next, we'll also need a small breadboard, and we'll use this to connect our circuit on. We also have a transistor, and this is an NPN transistor that we'll use to boost the power or boost the signal to the infrared LED. Then a TV, of course, that we want to control, and the corresponding IR remote for the TV. And of course, to finish it off, an Amazon Alexa enabled device. Here I have an Echo Dot. So this is actually what we'll be using to control our TV when the project is finished. So those are a list of all the parts that we'll need for our project. The first step in our project is to get our Raspberry Pi up and running. So after you connect all the various components for the Raspberry Pi, you want to head out to the raspberrypi.org website, and here we will download the latest version of Raspbian. So here the version of Raspbian is the Raspbian Stretch with Desktop. Go ahead and click on Download Zip. You'll save that to your computer. And next up, we're going to flash the SD card with this Raspbian image. To do that, the easiest and simplest way is using the Etcher software. So at the website etcher.io, so go ahead and download Etcher. And here we can see there are different versions from Mac, Windows, and Linux. Download the version that's appropriate to you, and flashing the SD card is as simple as loading it in, selecting the image you want to flash, and then clicking on Flash. Setting up the components for our Raspberry Pi and flashing an SD card with the image for Raspbian are a sequence of steps that folks who are familiar with the Raspberry Pi ecosystem perform regularly, so it's very easy. If this is the first time that you have set up a Raspberry Pi, you've never done it before, I will place a link in the video description that will guide you through the process step by step. Once we boot up our Raspberry Pi, we will want to make sure that the system is first up to date. So go ahead and open a terminal, and we're going to type in here sudo apt get update, and this should go out and update all our packages for us. Once that's finished, we're going to actually upgrade our system to make sure that it is up to date with all the latest software. So we're going to do a sudo apt get dist -upgrade. And this may take a while, but essentially what this is going to do is going to go out and get all the updated software for our Pi. So go ahead and type in Y here to confirm yes, hit enter, and we'll let this run for a while. I'm going to pause the video and we'll pick it up again once this has been completed. Okay, so now that our Raspberry Pi system is up to date, the first bit of software we're going to install is Flask Ask. And essentially Flask Ask is a Python library that was written by John Wheeler, and it allows us to quickly create Alexa skills for Amazon Echo devices. And although there has been a Python SDK that has been released by Amazon, which is in beta, Flask Ask still remains to be a viable option for a Python library that allows us to quickly get our skill up and running. So now, First, we want to update pip, which is our Python package manager. So we're going to type in here sudo -h pip 3 install --upgrade pip. And this is just going to ensure that our version of pip for Python 3, pip 3, is up to date. And we need to do this in order to pull down the latest updates for Flask. So now that has been installed, let's install Flask. So we can type in sudo pip 3 install flask-ask. Hit enter, and this is going to go out and get all those Flask-ask dependencies and so on and install Flask-ask for us. The next bit of software we have to install is called Enwrap. So let's open up a Chromium browser, and we're going to go to enwrap.com. So what Enwrap does for us is that it allows us to expose a publicly available URL from our Raspberry Pi. When we configure our Alexa skill, we'll be running a Python skill handler program on our Pi, and in order to access this, it has to be made publicly available via an HTTPS URL. This is what we're going to configure when we set up the Alexa skill in the Amazon Developer Portal. So by installing Enwrap, we're able to tunnel HTTPS traffic to our Raspberry Pi and access our Python skill program. So go ahead and click on the download link, and we're going to download the Linux ARM. So here we're on our Raspberry Pi. And let's go ahead and check the downloads folder here. And here is the Enwrap zip file. We can simply right click and just do extract here, and that's the Enwrap executable. So that's all we need to do for now to get our Enwrap on our system. Next up, we need to install Lurk. And Lurk is the acronym for Linux Infrared Remote Control. It essentially will be the software we'll be using to decode and send infrared signals from our Raspberry Pi, and it's pretty handy in that you can record remote signals and programmatically send those signals out to an infrared LED on a circuit. So that is essentially what we're going to do. So let's get Lurk installed. From our terminal, we're going to run sudo apt-get install Lurk. And that's going to go out and get all those packages for us. Type in Y, and this should run for a little bit, and when it's done, Lurk will be installed. Alright, so that completes the setup for the software that we're going to need on our Raspberry Pi. Next, we're going to move on to building our infrared circuitry so that we can communicate with the infrared receiver and infrared LED with our Raspberry Pi using Lurk. Now let's take a look at the IR circuitry that we need to set up for our project. First, we're going to review the circuit diagram. First, we will connect the pin 1, or the 3.3 volt pin on our Raspberry Pi, to the positive rail on the breadboard, and we'll also connect pin 6, or ground, from the Raspberry Pi to the negative rail. In that way, we can run several other connections off of these main power rails. Let's first take a look at the infrared LED. The longer pin on the IR LED, or the anode, is connected to the 3.3 volt rail. The cathode, or shorter pin, is connected to a 100 ohm resistor, and the other end of that resistor goes to the collector of our NPN transistor. The middle pin, or the base of our NPN transistor, is connected to a 330 ohm resistor, and the other end of that resistor is connected to GPIO pin 22 or pin 15 on the Raspberry Pi. The emitter of our NPN transistor is connected to the ground rail. Last but not least is our infrared receiver, and the VS or VCC pin on our infrared receiver is connected to the 3.3 volt rail. The middle pin or the ground pin is connected to the ground rail, and finally the output pin is connected to GPIO 23 or pin 16 on the Raspberry Pi. That's all the wiring that we need, and that completes the review for our circuit diagram. Let's now proceed to wire up our circuit. Okay, let's get started wiring up our circuit. Here we have the Raspberry Pi, and let's first connect the 3.3 volt and ground pins. So I'm going to take one of these female to male connectors here, and this pin on the left here is our 3.3 volt pin, and our ground pin is we're going to use the third pin down on the right. All right, so we're going to count down 1, 2, 3. This is going to be our ground connection. So I'm going to connect that to the breadboard. So let's use, this is a tiny breadboard. I'm going to use this top end here of the breadboard as our 3.3 volt rail, and I'm going to use the other end of the breadboard here as our ground. Next, let's connect our IR receiver. So this is our IR receiver, and if we look at the schematic for the pinout for our IR receiver, the leftmost pin here on the end, when the protruding part of the receiver is facing out, the leftmost pin is the output pin, the middle pin is the ground pin, and the pin on the right here is our VCC or VS, which is connected to 3.3 volts. So let's go ahead and insert this into our circuit. I'm going to orient it such that the output or the round part of the sensor is facing outwards, because we're going to point our remote to this part of the sensor and it's going to pick up the measurements. So when it's oriented like that, the leftmost pin is going to be our VS, is going to be connected to 3.3 volts. So I'm just going to simply take a wire and connect it from the 3.3 volt, the leftmost pin here, to our 3.3 volt common. The center pin is going to go to ground. So I'm going to make that connection now. Here is the center. Match that up along to the center pin, and that's going to go to ground. So we'll make a connection to ground here. And finally, the pin on the right of our circuit is our output, and the output is going to go to pin 16 on the Raspberry Pi. So we'll just make that connection. And the pin 16 on the Raspberry Pi is the 8th pin down on the right. So that's 1, 2, 3, 4, 5, 6, 7, 8. So just want to emphasize also, when you're connecting circuitry to the Raspberry Pi, make sure that it's powered off. That way you don't short anything out, and you can double check your circuit to make sure that everything is connected correctly before you power up your Raspberry Pi. So that's the wiring for the infrared receiver, and now we're going to wire up our IR LED. So here's the IR LED. We're going to put it on the circuit. Make note of the cathode and the anode. Of course, in this case, the longer pin here is our anode and the shorter pin here is the cathode. So I'm just going to insert that into the circuit. What we want to make sure is that these are facing outward in the circuit. That way we can orient our circuit and point it to our TV when we are trying to emit the infrared signals. Next to our IR LED, we're going to have our NPN transistor. And for the schematic for our transistor, when it's oriented like this, with the flat side, and the flat side is actually facing us, the leftmost pin here is the emitter, the middle pin is the base, and the right pin is the collector. So you just have to be mindful of that when you're connecting it to the circuit. So I'm going to connect the transistor on this side of the breadboard. So first, for our IR LED, the anode, or the positive pin, longer pin, is going to go to the 3.3 volt pin on our Raspberry Pi. So I'll make that connection now. This here is the anode. Okay, so I know it's a little bit difficult to see, but that's the longer pin. And I'm going to connect that to the 3.3 volt rail. From the cathode, we have to connect our 100 ohm resistor, and that is this guy here. So the cathode goes to a 100 ohm resistor, and the other end goes to the collector of our NPN transistor, and that is the pin on the outside. So I'll make that connection here. There it is. The middle of our transistor, or the base, has to be connected via the 330 ohm resistor to pin 20, GPIO pin 22 on your Raspberry Pi. So I will make that connection now. Here is the resistor going from the middle pin. And I will run this somewhere over here, and the other end of that goes to GPIO 22 on the Raspberry Pi. Okay, and that is the 8th pin down on the left. And finally, for our NPN transistor, the emitter has to go to ground. So that's the leftmost pin here on the circuitry of the transistor, has to go to ground. So here I'm going to connect the end of that transistor, and we're going to go to ground on the end here. Okay, so that completes the wiring for our circuit. Just ensure that your infrared receiver and your infrared LED is on the outside or the external periphery of the circuit. That way we can send signals to our TV, and also we can point our remote to capture signals. That completes the wiring for our circuit. So now we're going to work on configuring the Lurk software, Linux Infrared Remote Control, and this is what we're going to use on our Raspberry Pi to interact with the infrared circuitry for our project. So the first thing that we should do is open up a Chromium browser, and we're going to go ahead and download the code and resources for the project that I placed out on GitHub. So we're going to go to the following URL, github.com/liasam/alexa-rpi-tv-control, and I'll place this link in the description for the video. So once we're out on the GitHub site, let's go ahead and click on the clone or download button and download the zip file. And alternatively, you could simply clone the Git repository. So when we take a look here in our folder, we should see the zipped up code, and we can just simply right click and extract here. And now these are the files for the project. So go ahead and double click on instructions, and we need to do some configuration for our lurk. So the first thing we need to do is we need to edit the boot config.txt file, and we have to add in some parameters here for GPIO pins for the lurk library. So I'm going to go ahead and open up a terminal. We're going to type in sudo leafpad /boot/config. That's going to open up our config.txt file. And let's scroll down to the lurk entries, which is towards the bottom of the file. And the easiest thing to do is to copy and paste this line here. So we're going to copy this from our instructions, and we're going to paste that in right under the comments for lurk. Okay, so once that's added in, we can go ahead and click on File Save, close off that. Next up, we have to edit one more file, and that's the lurk options.conf file. So we're going to type in sudo leafpad /etc/lurk/lurk_options.conf. That's going to open up our configuration file. And there are two changes that we need to make. The driver, and those instructions are given here, is going to be changed to default, and the device is /dev/lurk0. So we're just going to make those changes here. Driver is default, and /dev/lurk0. And you could simply, of course, copy and paste the changes from here. And when you're done, you go ahead and save that file and close it off. So once that's done, let's go ahead and reboot our Raspberry Pi for the changes to take effect, and we will then test out our lurk install. So at the terminal, we could just do sudo reboot, and that's going to reboot our system. Okay, so now that our Pi is up and running, we can go ahead and open back up our instructions again from the downloads folder, just to have things handy. We'll be looking at a few of the commands to work with the lurk library, and we can go ahead again and open up a terminal. Okay, so the first thing we should test out is starting and stopping the lurk service. So to stop the service, we can do sudo /etc/init.d/lurkd, the lurk daemon, and we can do stop. Okay, and that looked okay. That command executed well, and that stopped our lurk service. And similarly, to start up our lurk service, we can type in the command and hit start, and it started it up. Another command that we can use to check to see if the service is up and running or what the status of the lurk service is sudo /etc/init.d/lurkd, and instead of start, we want to type in here status. And as you can see, it would tell us if lurk is up and running, and that's a good handy command to check on how things are going. There are also a couple of notices that you may see here to tell you if there are any errors or anything that you have to correct. Now we're going to check to see if the lurk driver is working. So this is the preliminary step before we begin to do the configuration for our remote. Alright, so I'm just going to clear my screen here. And first we have to actually stop the lurk driver. So we're going to do a sudo /etc/init.d/lurkd D stop. Once we get a confirmation that the service has been stopped, we're going to do a mode 2 -d /dev on lurk 0. Now we can take our remote, and once we point it to the IR receiver, we'll be able to press a button, and as you see, I'm pressing a couple buttons here, and we can see that the pulses are being recorded. So this means that our circuit was connected correctly and the IR receiver is working. The next step, just going to hit Control C here to stop that. The next step is we have to actually record our custom remote or register our remote device. So whatever TV you want to control, make sure that you first get the IR remote for that TV. And now we're going to actually program those signals in and store this as a custom configuration file. Let's type in sudo ir record, and I'm going to do a -d. I'm going to actually be doing the recording on the dev /lurk 0, and let's save that to a lurk d.conf file in our home pi directory. So go ahead and hit enter, and first it checks for ambient light to make sure that everything is okay and there's no significant noise, and it seems like we're good to go. So now you're going to enter the name of the remote, and I'm going to enter Sony here since it's a Sony TV that I'm working with. You can enter whatever name that you want. Just be mindful of that the name that you enter here, you'll have to change that device name in your Python code a little later on. So I'm going to hit enter, and now it's going to ask you to press many different types of buttons randomly, and it also says that you should hold them down for approximately 1 second. So we're going to go ahead and do that. I'm going to hit enter, and now I'm going to just keep pressing buttons, different buttons randomly here. It's picking them up. I'm going to keep going until we make a couple lines. Okay, so we're good to go. So now we're going to begin to register our keys. So the first key we're going to do is power. So the name of our key is key_power. You hit enter, and now I'm going to hold down the power key. I'm holding it down, and then that was recorded. So we're good to go on power. The next key is volume. We're going to do key_volume up. I'm going to hit enter, and I'm going to push the volume up key. Good. Next I'm going to do key volume down. Alright. Similarly, I'll push that, hold that up. Next one is key mute. Hit enter. I'm going to hold down the mute key. Good. Next up, we're going to do the channel up, key_channel up. I'm going to hit the channel up key, hold it down for a couple seconds. We're good to go. Next, I'm going to do key channel down. All right, that was good. Next, we're going to do the key_0. So that's the 0 key. And we're going to go through in sequence and program all the numeric keys. So that was key 0. Next up is key 1. Okay, so those should be the major keys, and then you can record any other keys that you may want. If you want to do input, display, or anything that you have on your remote that you want to record. And to get the names of these keys, there's actually a reference that you can use, and I'll post a link to this in the description for the video. Okay, so now we're done. After key 9, we want to press enter. That should finish the process, and it prompts us to keep pressing the same button as quickly as possible. I'm going to hit enter, and I'm going to keep pressing that button. Alright, so now that our file is written, we're going to back up the original file that was there, and we're going to copy over our new file to the etc lurk folder where it has to reside for the software to pick it up. So to make things easier, there are a couple of commands that I have included here. So let's just copy the first one, and that's going to simply move the file from its current location and rename it, actually just make a backup of it. So I'm going to hit enter there, and if we do an ls here, we'll actually see that sony.lurkd.conf file. The name of this file actually would be whatever you named your device. So now we're going to copy that and replace the original file that's there, and you're just going to change this device name here to the name of the device that you had entered. So in my case it would be Sony, so I'm copying that file to the etc lurk folder, and it's going to be copied to the lurkd.conf file. That's done, and that should be it for our configuration. The next steps would be actually to start up our lurk service, and then we're going to send some test signals to our circuit and see how that affects our TV. Okay, so now we're actually going to test out our IR circuit down in my workshop here, down in the basement. Might be a little bit noisy, but I have an older Sony TV setup here, and on this workbench you can also see that I have the Raspberry Pi set up. And what I did do was I put the IR circuit, tilted it a little bit forward so that the infrared LED is pointing towards the TV, and that way when we send instructions, the instructions will be sent to the sensor on the TV. So just orient your circuit a little bit so that it's facing the TV, and with that being set up, let's go ahead and I'm going to SSH to my Raspberry Pi here. Alright, so once I'm on there, now I'm going to navigate to the folder where we downloaded all the code for the project. So if I'm going to go to the CD till the downloads, Alexa, RPi TV Control Master, and if we look in here, there are a few files, and the program that we'll be using is test.py. It's a program that I wrote that would allow you to test out the infrared signals, so to ensure that we're sending them correctly to our TV. So let's first turn on our TV. So to do that, we type in Python 3 and test.py, and we do power on. Alright, so I heard it clicked on, so it looked like that is working and our TV is coming on. And if you need to make some tweaks to this actual test.py program, you can make those tests to ensure that maybe the power signal has to be repeated or and so on. You can make those tweaks and make the appropriate code changes. But I've tested this on several different TVs. The code seems to be solid, seems to be working. So it looks like we're good to go here. Next up, let's try increasing the volume. So we'll do the test.py, and the command is volume increase. Alright, so it's sending it, and it looks like, oh, there it goes, the volume is increasing. I'm going to make it a little bit louder. Alright, it's even louder.
And tournaments this year. Yeah. Well, everybody was
Now I'm going to
because you
decrease the
weren't there.
volume.
You know, and how about the open? The same thing apply to the open?
The same with the open this year. I'm not going to.
Alright, so it's decreasing.
I'm going to practice, and you know, I don't want to go through.
And here we go. We're going to decrease it a little again. Alright, so that looks at it like that command is working. Let's test out the mute. So I'm going to do volume mute. And looks like it worked. And to unmute, it's volume unmute. Alright, seems like it's working. So I'm just going to mute the volume so that you can hear my audio a little bit better as we go through the other tests. Next up, we're going to increase the channel. Now I have actually an antenna that is picking up some digital channels. So that's why you're seeing some older channels here. But I get about 25 channels. And let's try actually navigating up to see the next channel. So the command for that is going to do test.py. And it is surf up. So as you see, we go to the next channel up. Oh, it looks like it's working. And if we do surf down, we should come back to the previous channel. So that looks like we're good to go there. And the next one is actually navigating to a specific channel. So if we do channel and then type in the number of the channel, I'm going to do like say 57. Now I don't actually have a channel 57, but it's just proving the concept that, as you can see, 57 was entered, so it looks like those signals are reaching correctly to the TV. So to get it back to channel, I'm just going to do surf down. And it looks like we're back to channel that we had entered here, or we're back to a previous channel. So everything looks like it's good to go with the test. Now the next step is to actually get the program running on our Pi for the skill handler, set up the URL in our Alexa skill, and give it a go and test everything end to end. Let's check it out. Now we're going to create the Alexa skill that's actually going to control our TV. So let's set this up in the Amazon Developer Portal. Go ahead and let's open up a Chromium browser. And we're going to go to developer.amazon.com. And if you already have an Amazon developer account, you can proceed to sign in. If you don't have an Amazon developer account, you can click on the Create Your Amazon Developer Account button, provide a few pieces of information. It's free and you can set it up, but you'll need this to be able to configure your Alexa skill. So once you're set up, log in. And once you get to the main dashboard, you're going to click on Alexa. And under your Alexa consoles, click on Skills. And we're going to click on Create Skill. So this type of skill we'll be creating is a custom skill. And let's enter the skill name. We can use My TV, just like that. You can put the default language. I'm leaving it as English here. Again, it's a custom skill, so leave custom selected by default and click on Create Skill. Okay, so this is the skill dashboard where you can create your interaction model, your invocation name, intents, slots, and so on. To make things simple, I have already created the JSON schema for this skill. So click on JSON editor. And if you go back to your downloads, there is a mytv.json file. So you can go ahead and you can open this file up and you can copy all the contents from here and go back to the JSON editor and you can select all, Control A and Control V, paste that in here, and that should be the definition for your skill, your entire skill interaction model. Scroll up and you could click on build model. So build actually will do a save and build. We just want to make sure that everything is correct. It should take a minute or so, but once the model is successfully built, you'll get a success message. The only other bit of configuration that we need to do here is that we need to configure our endpoint, and that is the URL that we will access our skill handler code in Python when it's running on our Raspberry Pi. But we'll come back to set that up. Okay, so our build was successful. It looks like everything was good. And just to take a look, you'll notice for the intent, what we created here, we have one intent that's going to handle when we power on, when we give the instruction to turn our TV on. We have a volume intent that handles increasing and decreasing the volume. We have a go to channel intent, which is when we specify a specific channel, it's going to go to that channel, and then a channel surf up and down when we want to navigate the channel. So those are the basic intents that make up our Alexa skill. Okay, so the moment of truth. Now we're going to test everything out end to end, and I have SSH to my Raspberry Pi here to make things a little easier. So first things first, we're gonna navigate to the folder where we downloaded the code for the project. So that was in downloads, Alexa, okay, and our program that we're gonna run is the my-tv.py. So let's do that. So while it's starting up, we also need to run Enwrap. And remember, Enwrap is going to give us an HTTPS URL to our Raspberry Pi. And in that way, we have to configure that URL in our Alexa skill. So we're going to go to the downloads folder. And here actually is where Enwrap is. So we're going to start up Enwrap. And it's on HTTP 5000. So we're gonna execute this and it should fire up, and there we go. Here is our HTTPS URL that will port forward to localhost 5000 on our Raspberry Pi. Now we gotta log in to the Amazon developer portal, and we're going to log in here. And once we log in, we're going to go to our skill. So I'm going to click on Alexa, and in the skills, we're going to click on the My TV skill, and we're going to navigate down to the endpoint. Here we will specify an HTTPS endpoint. And here is where we will paste in that URL, our Enwrap URL. And the SSL certificate type is an endpoint that has a wildcard certificate. So choose the second option here, and we're going to choose on save. All right, so now it's time to test out our Alexa skill. In order to do that, we need to go to the Alexa app on our smartphone or the Alexa website, and we need to enable the My TV skill. So if you log in with the same developer account, you install the Alexa app on your phone, and if you go to your skills, you should see the My TV skill show up, and you need to click on enable. So once you do that, you're enabling the testing of that skill on your particular device, and I'm doing that right now, and it has been enabled. So without further ado, let's give it a test. Now I'm going to unmute my Alexa. Alexa, tell my TV to turn on.
Turning your TV on.
All right, TV is on. Alexa, tell my TV to increase the volume. Wow, looks like
Increasing
it's...
volume.
That's awesome. Alexa, tell my TV to decrease the volume.
Decreasing volume.
Alexa, tell my TV to mute the volume.
Mute volume.
Alexa, tell my TV to unmute the volume.
Unmute volume.
Alexa, tell my TV to increase the volume.
Increasing volume.
Alexa, tell my TV to channel surf down.
Channel down.
Down.
Channel down.
Down.
Channel down.
Down.
Channel down.
Up.
Channel up.
Up.
Say stop when you have reached a channel you like.
Stop. Alright, so it looks like everything is working well. The last thing is I'm going to ask the TV to navigate to a specific channel. So let's try that out. Alexa, tell my TV to go to channel 55.
Channel change to 55.
Now, I don't actually have a channel 55, but I just want to ensure that that's working. But essentially, since I have an antenna with digital signals, the channels are, 55 dot something and so on. So just want to make sure that that works. But it looks like it's working. That's pretty cool. Alexa, tell my TV to go to channel 89.
Channel change to 89.
Alright. Alexa, tell my TV to channel surf down.
Channel down.
Alexa, tell my TV to power off.
Turning your TV off.
Alright, so there you have it. It's all working. We got our Alexa custom skill to work with our Raspberry Pi to control our TV using only our voice. What an awesome project. Hope you really enjoyed this tutorial, and if you like this, be sure to subscribe to this channel. If you want to learn more about the Raspberry Pi and build cool, fun, and exciting projects like these, check out the link to my course in the description below for the video. If you have ideas for projects that you'd like me to build, leave a suggestion in the comments for the video. I'll be checking for feedback often, and I'll tackle some of those projects that you recommend. Till next time, bye for now.